And that is the last polar graph you will ever have to do by hand. But I want you to do one because I want you to like really see how the plotting points and how it works. I was off on one of my points. I put it too far, right? It's supposed to be on this line. It was on this one. So that's really supposed to go like that. I found the negatives were pretty difficult to do because you have to keep a track that you're on this angle, but the R is negative, so you're actually plotting down here. It was pretty hard to know like what angle you were at, especially since the calculator is only giving you decimals, so it's hard to tell what angle you were at, but you can figure it out. So another thing that I thought was interesting, you'll see this happen a lot in your calculator. You get things like this, 2e to the negative 12. All right, so of course that's scientific notation. It means 0.00000000002, and of course it's really 0. All right, so what's really going on is that your calculator rounded the value of delta theta because it doesn't really exactly have 5 or 24, and then it rounded its calculations and it didn't end up with exactly 0. But anytime you hit a number like that in your calculator, your calculator sometimes returns a very small number when what it really means is 0. All right, so we'll keep that in mind. Now, the next thing we're going to do is we're going to learn how to make our calculator just do this whole thing. So this one you're going to turn in by hand. The next set of problems, let's get the right page here. These problems, I'll make this clear in the assignment, but when it says sketch the complete curve, right? Find an appropriate graphing window. Use a graphing calculator to produce the polar curve, then sketch the complete curve. Okay, so you could just take a picture of your calculator output and include that in your assignment that you're turning in. And when it says identify the type of curve by name, starting here on page 555 is a bunch of different functions and their names. So this thing that we did is a rose curve with 3 petals. Yeah. You have lots of cool things like the Limousin curve. That's French. It's got the little tail on the C. Limousin. Pretty sure it's French, not Portuguese. And then lemniscates. Lemniscate, Limousin. Okay, so they're very cool. And of course, your basic spiral. You know, does Archimedes really get to put his name on the spiral? No. There were spirals around before Archimedes. Take his name off of that. People just put different mathematicians' names on whatever just because they're famous. All right. I'm not resentful or anything just because my name's not anything except peanut butter cups. Okay. We are going to look at number 14. So this is page 557. Everything here, and I have this correct this time, is in section 10.3. Page 557. So I'm just going to show you a couple of these graphs and show you how to do this in your calculator. So we're going to do number 14. It is r equals -3 sine 2 theta. Very exciting for me because I have no idea what it looks like, but you need parentheses there, people. I'm talking to the authors of this book. All right, now, so how are we going to get our calculator to do this for us? It's pretty nifty. So we're going to go to mode. And down here, remember where we do func and pair for function and parametric? All right, well, now we're going to do pole for polar. Speaking of pole, I'm going to drop my tripod pole. Oh, maybe I already dropped the tripod. All right, polar. So we've used now function, parametric, and polar. We are going to use sequences before the end of the class, so we'll have used all of your nifty things here. So I just hit enter. Now I'm in polars. Now, when I go to my y equals, look what I got here. Instead of y's, I got r's. And I've already put in the function, and it gave me a theta instead of x. Nifty, huh? Now, it says on an appropriate window, this isn't actually this graph, is it? This is 7 sine of 3 theta. That's this graph. Well, let's just do it just for kicks. We'll do it on a standard window, so that's zoom 6. There you go. Now this one looks a little squinchy. An important zoom feature to know is zoom square because the x-axis is not commensurate with the y-axis, not proportional. Well, it's proportional, but it's not equal. So we can go zoom square, and what that does is just even up the x's and the y's. So now the x's and y's are equal. We can see that the shape has some nice symmetries that we would miss otherwise. All right, we're doing this one, -3 sine of 2 theta. Oh, I can't wait to see what it looks like. So -3 sine of 2 theta. See, right when I push the X button, it's xt, theta, or n. And it just gives you the correct one. I had too many parentheses. See, even the calculator knows you're supposed to have parentheses there. Authors of your book don't know that, but your calculator does. All right. Yeah, that looks good. We'll just start on a standard window. Let's see what it looks like. It's a little tiny, right? You know, it's weird looking and tiny. All right, so let's start by zooming it up. We could probably just do zoom in. Oops, that's not zoom. Zoom in. There we go. Yeah. Okay, so what is that? So now I take a picture of that, include it with my homework. I come over here and match it up with something. I'm pretty sure that's one of these guys. Oh, see, look. See, all of these are rose curves. And it's actually pretty interesting to look in here which ones have which kind of symmetry, depending on whether it's sine, cosine, even, or odd numbers, and which ones have n petals, which ones have 2 n petals. That's all pretty interesting. I'll leave it to you to look at. It's nifty. So we're going to say this one is a rose curve. Let's be nice and call it a rose curve with 4 petals. See, it's very nice and floral. All right, let's see what number 16 is. Number 16. It says r equals 3/2 plus cosine theta. I also hate writing fractions like diagonally. So write them vertically. Come on. All right, let's see what this one looks like. 3/2 plus cosine theta. And of course, you know, you're always encouraged to just sort of experiment around and come up with your own functions. That's one of the really fun things that you can do with math is just, let's just make up something and put it in there. Who knows what? Cosine theta, ding, close parentheses, let's graph it. Oh, look at that. It's like an apple that somebody pulled the stem off of. All right, so I clicky, put a picture of that in with my homework, and then let's match it up. Does it look like something here? Does it look like one of these? It sort of looks like that one, a limison. I mean, it's really sort of more like this one, but rotated. So it's sort of more in this category. Oh, I never noticed this before. Look, a dimpled limison. Oh, that's so sweet. Right? You get this one up here. So these are all types of limisons. So they all come out of certain, you know, a plus or minus b cosine theta, right? So you get a limison with a loop. This one is heart-shaped, therefore cardioid, right? Like cardiac means pertaining to the heart. Cardioid. This one, I've been teaching calculus for so long, and I never in my life noticed that there's a thing called the dimpled limison. And then this one's a convex limison. See, it's like sort of like an asymmetrical circle. All right, so now I get to write for the first time in my life. I've never written this before in my life. That is a dimpled limison. Love learning new stuff. Nice. Okay, so basically that's just about how your calculator can do these. So next up, we are going to say, you know what you want to do with a new kind of function like r of theta. You want to be able to do derivatives and integrals. Derivatives are today, integrals are tomorrow. That's what's up next is derivatives.